Hello again, class. You're probably watching this video immediately after you watched the graphing sine curves video. So we're just going to see what the cosine curve looks like and why it's a little different than the sine curve. Now, it should be obvious that once we start sketching our circle, why all of the numbers on this curve are different. And that's because when we did sine, we looked at all of the y values, but now we're going to look at all of the x values, and it's just going to change what the graph looks like a little bit. It kind of like steps the graph forward one step. You'll see what I mean as we finish completing the coordinates for around the circle. So that's -1, 0. This point over here is 0, -1, and now we're doing all the x values. So the cosine of 0 is 1. The sine of cosine of 90 is 0. The cosine of 180 is -1. The cosine of 270 is 0, and the cosine of 360, we loop back to the beginning, is 1. So this graph starts at 1, at 0 degrees. So at 0 degrees, it starts at 1. Then we're going to go to 90 degrees, 180, 270, and 360. So again, that's pi, that's 2 pi. This is 3 pi over 2. And this is pi over 2, or half of a pi. This is 1.5 pi's, and so on. We're going to go down to -1 at some point. So the graph started at 1, goes to 0, then -1, back to 0, and then up to 1 again. So this graph actually cycles like this. I didn't mention it before, but if we did, this is 90 degrees, so if we did a third of the way, 60 degrees, this would be a half, and then 1/3 of the way, this will be radical 3 over 2. So we have our decimal values between 1 and 0 appearing on this graph, but this is the cosine curve. So if we look at one of our examples, a cosine curve will start at the top, go through its midline, so the midline is actually here, and then go all the way up to the top again. So this is one period of this graph. So let's take a look at the values here. The midline in this case, as we can see, passes through 1. So y equals 1 is our midline. Our graph is supposed to start by starting at the top and going down. So this is a positive amplitude. The amplitude is from the center to the top. So that's 1 unit. So our amplitude is 1, and because the graph is following its normal direction, it's positive. The period in this case appears to be 12 pi. And the frequency, in this case, how many complete cycles does it do in 2 pi? Well, 2 pi is over here. So that's actually hard to tell exactly how much. Obviously, it didn't fit nearly an entire cycle into this, so we're going to use our formula to see it better. So the frequency, the b value, is equal to 2 pi divided by the period. So that's going to be b equals 2 pi divided by 12 pi in this case. So that means our b value is going to be equal to, the pi's cancel out, 2 over 12 is 1/6. So 1/6 is our frequency. So 1/6 of a cycle made it in here, which makes sense because it took, it'll take 6 of those to do 1 pi and then another 6 to do 2 pi. So our frequency is 1/6. So if we were to write this as an equation, this would be y equals, our frequency, our amplitude was +1 because we had a graph that went normal direction and went up to its highest point 1 above. The cosine of the frequency, which is 1/6, theta or x, whatever you'd prefer as your variable. And our midline was 1, so +1. So this is the equation of this particular graph. You can try most of the rest of the examples on your own. I wanted to address a few things in reference to like calculators. Like if you wanted to graph these using your calculator, which I didn't address in the previous video, just because the previous video had a lot of things to do, you're going to want to put your calculator in radian mode. Part of the reason for that has to do with normally when you graph, your graph would only go up to, this is not the best calculator for this, but it would only go from -10 on the left to 10 on the right. And if you were in degree mode, you wouldn't see 360 degrees because it'd be far to the right. So if you're doing it in radian mode, you're doing it to 2 pi, which is 6.14, so it'll work a lot better that way. All right, let's take a look at some regions problems. So let me just get this on the edge here and move that away. Just gonna scroll down to some of the regions problems on the back, because we didn't look at any of them for the sine worksheet. So this is problem, let's just pick a problem. It doesn't matter which one we do, because they're all essentially the same. Let's do problem 5 and problem 50. So problem 5, which function's graph has a period of 8 and reaches a maximum height of 1 if at least one full period is graphed? So in other words, obviously you don't reach your maximum if you don't graph the entire period. But this graph, the first one here, let's just take a look at what it would look like. Well, the middle of the graph is at -3, because that's the midline. It goes the opposite direction of normal, so it'll start at the bottom, go up, and then all the way down again. So this is going to be at -7 as its minimum value, and its maximum value is at +1. So from the middle, it goes up 4, and it goes down 4. But the graph is upside down, so that's where the negative comes in. Now, as to what the a period of 8, we'll have to use our formula. So the period is equal to 2 pi divided by the frequency. So in this case, the frequency is pi over 4. So P equals 2 pi over pi over 4. I'm going to make this over 1 so I can do keep, change, flip. So period is equal to 2 pi over 1 times 4 over pi. Pi's cancel out, and I get 2 times 4, or the period is 8. So the answer is either choice 1 or choice 2, because those have the period we want. If we would do problems 3 and examples 3 and 4, they're going to give us a different period. So it says what as a maximum height of 1. Well, we see that our maximum height of 1 occurs on this graph, so it should be this one. It says which function reaches its maximum there. If we look at +5, then if this was +5, then this would have been at 9 for the maximum, and the minimum would have been at 1. So our correct answer seems to be the one we started with, which, is coincidence. So the correct answer is choice 1. Let's take a look at problem 50. Actually, let's take a look at problem 24 real fast. It says the graph of the equation 3 cosine of x is symmetric with respect to what? So if we were to graph 3 cosine of x, it would start at 3, and the midline would be at 0. It would look something like this, and because it's a periodic function, it would actually go back the other way. And if we're looking for symmetry, it'll be symmetrical about this axis, which is the y-axis. Now, by being symmetrical about the y-axis, this is actually considered an even function. All right, and let's take a look at problem 50. Problem 50 is actually a question about sine, so we need to know the difference, which is why I didn't want you to do the assignments on delta math until you saw this video as well. It says, which graph represents a sound wave that follows a curve whose period is pi, and that is in the form of a sine equation. So a period of pi means it completes its full cycle by 1 pi. So in other words, in 2 pi, it should finish 2 cycles. So this doesn't work because it's a cosine function. This is a sine function, but it completes 3 sine curves. So that means the period should be 2/3 of pi for each of them. So this is 2/3 pi, and this is 4/3 pi. The next one is also a sine curve. It finishes 2 of them, so this is at pi and this is at 2 pi, so this should be our correct answer. And just for completeness, this one has a period of 2 pi because it completes the full cycle of sine at 2 pi. Please try the rest of the examples yourself. If you have any questions, make sure to ask in the Google Classroom, either on the day's post or in the classwork assignments private comments or your individual class's private comments.